Hi there, Francis Potter here, GitLab Solution Architect. I'm going to talk to you about merge trains. It's a feature of GitLab that we are extremely proud of. I've made other videos about it. I'm going to try to explain a little bit better why merge trains exist. What is the reason you might want to use them? What are the conditions under which merge trains can make a huge difference for you and your software development projects? So if we step way back to the main goals of source code management in DevOps, I'm really identifying two goals here. The first one is develop and release new features and bug fixes as quickly as possible, right? You always want to be developing as fast as possible and releasing as fast as possible, but you also want to keep your default branch green. And this is really important if you're working at a high velocity, because if your default branch becomes tainted, it goes red, then it can kind of bring your entire development operation to a halt while everyone tries to figure out how to fix it. And so you never really want that to happen. So let's look at just some terms here. Now, if you look at this chart here, this is time along the x-axis, and each of these rows is a merge request. So in GitLab, we use merge requests to track changes on feature branches. All right. And if the merge request is finished here, then it takes a certain amount of time to run tests. And I'm just using the word tests to refer to everything that has to be run on that merge request after the last commit and before it's merged. So that may include unit tests, integration tests, code quality scans, license scans, other kinds of application security testing, might even include code review and other steps that have to happen, right? So you have your time to run tests. And then there's another variable, which is the periodicity of the MRs. How frequently are new MRs ready to be merged, right? And if the time to run tests is generally shorter than the periodicity of the MRs, then you're good, because you're in what I'm calling the low velocity development mode on that particular project. Maybe there's a small number of developers, maybe changes are occasional, maybe test runs are short, but in any case, to keep your default branch green, developers on feature branches might have to upmerge or rebase from the default branch before they can merge down, but you could still keep your default branch green. However, that all starts to fall apart in a higher velocity use case. So when I say higher velocity, I mean where the periodicity is less than the amount of time to test, right? So you've got merge requests coming in frequently, 1, 2, 3, 4 coming in frequently. So notice 4 MRs have been completed before the first one is even done testing. Now, in this case, even if you reduce to 0 the amount of time it takes to actually do the upmerge and rebase, you obviously just sort of like stretch your timeline out infinitely, right? Because you want each developer or developer team to wait for the previous one to finish before they can merge theirs. And you end up with this situation where, you know, the user that created MR4 is just waiting forever for MR3 to finish. And obviously that's not tenable. And this is where merge trains are just an awesome feature. So what the merge train does is it allows you to run these merged commits essentially in parallel. So this is still in a situation where the periodicity is shorter than the amount of time to run the test. And the merge train functionality runs the test suite or whatever your CI jobs are on combinations of MRs, okay, even before they are merged. So when this is run on MR1 plus MR2, they have not been merged yet into the mainline default branch. That doesn't happen until those tests are complete, right? So it's actually we call it like a pre-merge, a pre-flight test of MR1 plus MR2. We're also running a pre-flight test of MR1 plus MR2 plus MR3. So notice MR3 is getting done a lot sooner than it was on the previous slide. Now, it only performs the merge when that combination completes successfully. That's great. What happens if one of them fails? So in this case, MR3 failed. And what GitLab will do, because it's smart, is it will start over MR1 plus MR2 plus MR4. So assuming that your test suite is thorough, we are actually able to merge MR4. MR3 did not merge because there was a problem with it. So the developer of MR3 has to go back and fix their code, but the developers of MR1, MR2, and MR4 are all done. And all done even with a failure much more quickly than the equivalent process without the merge train. So merge trains are about the situation where the periodicity is shorter than the amount of time to test, especially on large projects or projects with a lot of complicated work going on. And essentially, they allow you to maximize your velocity while keeping your default branch green. I hope this helps. Yeah, enjoy.